Hi, in this video we are going to talk about the introduction to design of reactors for single reactions. This is kind of like the starting, and from this video onwards I will be talking about the reactor design specifically for single reactions, and I will talk about single reactors and also about multiple reactors one by one, but treat this video as a very basic intro to the entire topic. Now, when I say I'm going to introduce the topic, let me just outline what reactor design is altogether from the perspective of a chemical engineer. So, if you say that you have a reacting fluid, okay, and you want to process it through a reactor, now you can process it through a single batch reactor. Let's say this is a batch reactor. You can process it through that. You can also process it through a flow reactor. Let's say you have a tubular coiled reactor. So you can use that also for processing the fluid. Okay, this is a flow reactor. You may also use a chain of reactors. You may use a chain of batch reactors. You may use a chain of flow reactors. Okay, so chain of batch reactors, let me draw. So you have batch reactors. Okay, and it's not necessary that they are in series, they may be in parallel also, but since I'm saying using the term chain over here, I'm just going for the series kind of configuration. So batch reactors in series, you may replace this with with flow reactors in series. Then again, there may be interstage feeding of the reactors. Okay, so between two stages there is some feeding. There may be some heating in between the stages or in both the stages. So heating is another factor that you may consider. Then you may also have a recycle stream. Okay, so some ratio of the product is sent back as a recycle. And what is the feed to recycle ratio? That may also be a criteria. What should be the recycling condition, whether there has to be any heating involved in this part of the process or not. Okay, so there are many schemes that you can consider for reactor design. Now, which scheme should we consider for a given case? To answer that question, we have to consider different factors. Now, what are these factors? Okay, one is your reaction type. Now, since I have already said in the title of this video that I'm going to talk about single reactions, so I'm just going to say that for the sake of single reactions, we are going to go on ahead. But in a general case, there may be multiple reactions involved. Okay, so that is one case. Then also you have, let's say, the required yield. Okay, or how much production you actually require, right? Scale of production. So I'm writing it in short: scale of production. Then another very big factor is an economic factor, that is the cost of equipment. Okay, cost of equipment. Then the profits that you can garner out of this like setup that you have for your plant. Then another very big factor, safety. Okay, process stability, process feasibility, and how flexible the process is. By flexible, what I mean is that, let's say today you set up a plant, okay, and you have a reactor which is processing, let's say, a, a single ton of fluid. Okay, but after few years you see that, let's say, within 1 year you see that there is an increased demand in the market for the particular product that you are giving. So in that case, you want to scale up the production process. So you have to see whether your equipment setup is flexible enough to accommodate the new requirement, right? So that answers the like criteria for flexibility. So all of these factors are very much kind of they're interconnected. Another thing I missed out while talking about flexibility is that whether it is also convertible to modified operating conditions. What do I mean by this modified operating conditions? Okay, so let's take an example for this. Let's say you have a plant where you have one batch reactor and you are processing fluid A. So there is some reaction and you are getting the product R. Okay, simple, fairly simple. I'm not going into recycle and all of those things. It's just a simple reactor. Now this A is coming from some other factory. Okay, so when you purchased A for your plant, you said that I want A with this particular characteristics. Let's say A will have certain, like let's say 50% of inerts in the mixture. I mean here A plus I, I'm not writing I altogether, I'm just writing it as a feed. So let's say it can have 50% of inerts and 50% will be pure A, the component A itself. But after maybe 6 months of operation, you see that all of a sudden the percentage of inerts have gone up. It is around 60% inerts after some point of time. So at that time, to meet the same rate of production of the R component, you may have to modify the operating conditions. So is your reactor which you have already set up for this process easily able to accommodate that modified operating condition? That is another question that you have to think of when you design the reactor as a chemical engineer. So like you can understand, obviously we have a lot of schemes, and to consider each scheme we have so many of these factors. Okay, so that gives us a very wide choice. And once you have made your choice, let's say you have gone through 10 options and you have brought down to two, two suitable options. So then your task will be to find out which is the most optimum setup for your process. That is the ultimate goal. Okay, and I am putting a lot of stress on the word optimum. So you will be finding the optimum setup ultimately. That is your major goal. Now, obviously, this kind of understanding comes with a lot of experience, but as a basic, uh, starting point for understanding reactor design, we are going to consider that we'll deal with single reactions. Okay, so that leaves us with the option of choosing amongst the other factors, that is yield requirement, scale of production, economic, safety, stability, and so on. Now here we are not going to consider this economic aspect again. Okay, so economic aspect comes much later. We are going to focus solely on the production and the type of reactor required and the volume of reactor required. These will be our goals for this part of the study. Okay, another thing, safety comes a lot under the process control regime, but we'll be touching upon it a little bit over during the reactor design also, especially when we are dealing with processes which are, let's say, exothermic in nature. Okay, so in that case, we'll have to consider the safety during design as well. But if you consider these overall problems as actual research statements or in industrial level problems, then safety is actually built into the reactor design itself. That is also done, and that's a different study area altogether. But coming back to our point, so we are going to deal with single reactions, like I have already mentioned twice now. So we'll talk about single reactions, And we are going to assume that there is only this one rate expression which is sufficient for describing the entire system. Okay, and this brings simplicity to the problem, because we can then just focus on the volume or size of reactor. Okay, we are since we have a single reaction, we do not have to worry about the product distribution. Okay, so we can focus solely on this volume or size of the reactor. Then we will build up our study for multiple reactions later, but this is what we'll do for single reactions. That is it for the introduction. Thank you.